Hello everybody. This video is a presentation of our publication in Economy, Law and Policy. The link you can see here below, the Department of Information, or you can just search it in the journal as you can find it. The title itself of the publication and of this video is the effects of the COVID-19 measures on the economy and the environment. As you know, we've had lockdowns. We have actually had a pandemic of a virus, the SARS-CoV-2 virus, and the illness itself is called Covid-19. And our governments all over the world had decided to stop the economy, to halt it, to put everybody at home, so not produce any goods. In this way, hoping that the virus would be eliminated from the world. Now we can actually think about if this had any effect itself on eliminating the virus, which actually is very dubious. At best, it probably just postponed the inevitable. But this is not the subject of this video. The subject of this video is if stopping the economy actually had any effects on the economy itself, on our wealth, and then on the environment, and more specifically on the atmosphere. Because as we know, the economy that we're having, we're burning fossil fuels for that. And these fossil fuels, the carbon, winds up in the atmosphere and then allegedly is heating up our planet. So the idea of this heating up the planet we have already treated in other publications. So this publication mainly goes about, well, actually, did we have any effect on the atmosphere? How much was the effect the stopping of the economy had on the dynamics of the atmosphere? And therefore, this is very significant for the environment, namely for the climate. If you then believe the second step that the atmosphere is responsible, the CO2 in the atmosphere is responsible for the climate changes that are or not taking place. These are all different subjects. Here we focus on the measures fighting COVID. Actually, what did they have on the economy and on the atmosphere? So just to give you a background here, this picture that you see here on the background behind me, this is the Faro, the place where I live, during the lockdown. And as you can see, everything is stopped. All the cars are stopped. Not a single person in the road, even though the nature is beautiful as ever before. Now, to address this, I will, to summarize this entire video, the entire our publication, the question that will be answered is that for fighting this virus, actually the pandemic that is associated with the virus, actually the question is going to be answered is how did these measures fighting that illness, how much did it have impact on the economy and on the atmosphere? So this is what we're going to answer today. But for that I have to go put a little bit a step back, because I want to take you back to earlier publications that were written. And that is, for instance, this one from Modern Economy 11 from 2020, so from the year before, in which I did draw the conclusion actually that economy is energy consumption. The only valid unit of the economy is energy consumption, so that is what? All other units of expressing the economy, they are nonsense. And this sounds maybe a little bit strong to say, but actually this is correct. Because as I have already put in another works, is that everything that exists can be measured, and everything that can be measured has a unit in the Système International d'Unité, or in other words, SI. If it exists, it has an SI unit. If it doesn't have an SI unit, it doesn't exist. And these dollars and euros, those are not SI units. So this is probably not a good unit of expressing the economy. And I will actually show you that this is indeed not the case. The real things, what really happened, is actually energy consumption. And that is the unit watt. So what we should do is express the economy in watt, and not in euros or dollars or whatever, but in watt. And this is not a new theory of mine. I'm not so smart that I can invent theories like that from scratch. This is just rephrasing the theory of the classic economists, such as Marx and Adam Smith. They called it the labor theory of value. And if you read these books and if you understand what he's saying, then, for instance, Marx talks about the toll and labor that went into a product. The value of a product is the toll and labor that went into producing it and bringing it to you. And intrinsically, he talks about the human toll and labor, because everything was, in his philosophy, was centered around, for Marx, centered around human philosophy. So that means that if humans put toll and labor into it, humans have the right to consumption of these things. But from a physics point of view, humans do not have a special role. It's maybe more religious, but for physics, there is no such preferential place of humans. A human is just a machine, just like any other. So if a machine nowadays, if a machine is producing something and consumes energy to produce it, that is just as much valuable as that a human has produced it. Imagine the TV, the screen maybe you're now watching, or your tablet or something like this, was produced by a machine. Does that make it less valuable? No, of course not. So we should skip this idea that humans have a central role in the economy. It is just everything is energy consumption. So instead of talking about labor, we should talk about energy. And labor, anyway, labor and work, they are archaic terms from physics that are no longer used so much anymore. But to give you an idea, work is just force times distance, as we all know. Actually, the German is the word for it is Arbeit, where it means like it looks like work in the sense of that I have employment or something like this. But for physics, work is just force times distance, and that is the unit Newton meter. And that expressed in SI is exactly the joule. So actually what Marx is saying is also that he's actually describing the what I call the energy theory of value. And as you can see, this is published in Modern Economy 11 from 2020. If you're interested in it, I will also link it below this video if you're interested in this. And actually, this energy theory of value is just a rephrasing of the labor theory of value. But what we have to keep in mind from this entire words that I'm using here is that economy is energy and nothing else. Economy is energy. So the unit of economy is what? Now, there is of course a link between energy and money, because before, in the early days, the money was gold, and 1 ounce of gold costs a certain amount of energy to mine and mint, so an amount of joule. Hence, therefore, we have economy that is energy, but energy is gold, and gold is money. Therefore, we can say economy is money, and we can express, until a certain moment, we can express the economy also in money if we want to. So we can use the dollars or the pound or the euro, because economy actually it can be expressed in money, because money is at the end was also energy. However, then the bankers started, I call them nearly banksters. I would like to call them banksters. They started using what is called fractional reserve banking, or the Venetian method, meaning that you actually print banknotes or write banknotes that promise gold. So somebody that has one of those banknotes can go to the bank and exchange it for gold. But fractional reserve banking means that you are printing 40 times more, about 40 times more of those banknotes than you actually have money in the safe. Now this can be called a swindle, because promising things that you can never ever fulfill, this sounds to me like fraud. But still, this is the international financial system, so this is actually what is being done in the world. And as long as this ratio between money and energy, or money and gold, is constant, let's say a factor 40, then still the economy is well expressed in money. Of course, it should be then corrected by a factor 40, but if the money is growing in, if the economy is growing in monetary terms, it is also growing in energetic terms. So we could still more or less use money for expressing the economy. However, then we got the Bretton Woods monetary system, in which the link to gold was removed altogether. So the ratio between money and gold could be infinite, could be any number you want. The idea in Bretton Woods was that the international currencies are pegged to the dollar, but the dollar itself is no longer linked to gold in any way, and the dollar simply represents nothing. And this, by law, is actually a crime, because writing a contract that doesn't promise anything, or in this side a unilateral contract which is called a deed, which is not promising anything, is a crime. If my contract doesn't promise anything, then what I'm signing is a criminal piece of paper. And you can see, take a banknote out of your pocket, look at it, for instance a euro, you will see that on mine it still has the signature of Mario Draghi, and Mario Draghi signs this contract, but look at it, what he actually promises. And his promise is nothing, and promising nothing is a crime. The problem with this is, apart from that it's a crime, is that now the economy can no longer be expressed in money, because the economy now is money divided by any number that you want, can be anything. So we should no longer express the economy in dollars or euros, because that doesn't make sense at all. We should now go back to expressing it in what. Anyway, if you want to read more about this, I recommend my own book. I have to do some publicity. I'm sorry, I have to do some publicity about my own book. It's called Money in Gold We Trust. And as you can see, you can find it on the internet, I'm sure, or just send me an email. So that's about it. That's about the link between money and energy and the economy. And that is important for this economy, because we're going to look at these numbers in a moment. And then you have to keep this in mind, that energy is not in modern economy. Money is also not modern economy. So to continue now, of course, there still is an instantaneous link between money and the economy, and energy, because this ratio, that is this fractional reserve banking ratio, or the ratio between these two, between money and energy, this is at a certain moment there is a certain ratio between the two. And instantaneous, it can change over time, but at a certain moment there is a ratio. And I found here this information. You can see here on this picture, you can see here for all the countries in the world, horizontally the energy consumption per capita, and vertically the GDP per capita. And as you can see, there is a correlation between the two. There is, of course, a little bit a problem with that the market is not completely efficient. Therefore, the trades that are sometimes taking place between countries is not on a fair basis, that 1 joule of energy is exchanged for 1 joule of energy. For instance, 1 kilo of gold is exchanged with 1 kilo of grain. Does it have the same energy? Well, in a free market that is efficient, it would be completely exchanged fairly, meaning that with the same amount of energy that it represents. But in reality, it's not the case, so the market is not efficient. But as you can see, the relation between the two in this plot, it goes over, as you can see, about or more than 2 orders of magnitude for the GDP and for the energy consumption. But the relation is quite good. And you can see in this that in 2019, instantaneously, $1 of GDP corresponded to 170 milliwatt of power consumption. Well, this is all summarized in that Modern Economy publication. I cordially invite you to read that one, where these things are explained. So one thing, in 2019, the ratio between the dollar and power was $1 of economy per year was 170 milliwatt of power consumption. And this ratio between the two is not constant. This changes over time. And just empirically, so there doesn't seem to be, or I don't understand what would be the physical law behind it, but empirically, apparently the dollar grows with, the GDP grows with a fifth power of the power consumption, meaning that if the power consumption of the economy doubles, then the GDP actually goes with the fifth power of 2, that is 2 to the power 5 is 32. So then the economy grows with a factor 32 in money terms. Twice as much energy, 32 times as much economy. Now to see you that just before the pandemic, we got that in 2019, the year before, this picture I have to say again, it's a log plot. So we see here now the entire world economy, the gross world product. So we talk about all the countries together and the energy consumption per capita in the entire world. And in 2019, the energy consumption grew by 0.6%, and then if you take it, 1.006 to the power 5 is 1.031 approximately. So that is indeed the case. 0.6% growth of energy consumption, meaning 3.1% growth of the world economy. So everything continued on this fifth power law. I have no idea where this comes from, but this seems to be an empirical law. Once again, explained in Modern Economy number 11. However, now we go to the Covid-19 year, that's 2020, where we were hit by the pandemic, and all the governments in the world, or most of them, they stopped the economy. The result was that the power consumption dropped by 5.9% because the economies were stopped everywhere. Now, that if this fifth power law, this empirical law that we found on the previous page, was a physical law, that it is a solid law that is governed by physics laws, then the gross world product should have dropped by 26.2%. However, that is not the case. It only dropped by 4.5%, just showing you that this empirical law is based on no physics, but just let's say some office somewhere, maybe in the World Bank or something like this, is deciding that this should be followed like this, or this is how what seems to be makes the world most manageable or something like this. Anyway, the power dropped by 5.9% and the gross world products dropped by 4.5%. That's all very nice, all very well. What is important also for this publication and for this presentation is how much did we reduce the CO2 emissions, the carbon emissions. Interestingly, the carbon emissions dropped faster than the gross world product dropped, and dropped faster than the power consumption dropped. And that is probably due because fossil energy production can be, or consumption can be scaled down quite easily. You cannot switch off a windmill because it's there. It would be stupid not to let it run. And solar panels and things like this would be stupid not to let it run. But a coal central or oil energy central or something like this can easily be stopped to not consume fossil fuels. And in fact then the emissions, the carbon emissions dropped by 8.6%. That is quite a lot. That is significant, and therefore we should expect an effect on the atmosphere. So we can actually now test two hypotheses, and let's see if we can make a conclusion about these two hypotheses. After all, we are scientists and we test hypotheses. Science consists of testing hypotheses. So we have here two hypotheses. Number one, H1, is that all carbon dioxide increase in the atmosphere that we have been observing in the last decades is due, or was due, and is due to human activity. And this is basically what people, what we call the alarmists, are using, the IPCC. They're saying that the carbon dioxide rise in the atmosphere is caused by humans. Because, mind you, if it were not the case, if the CO2 is also rising from natural causes, it would mean that climate change, if they are caused by CO2, actually are unavoidable. And in that case, if it's unavoidable, then we might better enjoy the show that nature gives us. We better go on, while the Titanic is sinking, we better go on playing the piano and have a party. All get drunk and have a party because it's unavoidable anyway, so let's have fun. On the other hand, the other extreme is, we can test this hypothesis, what if all the CO2 increase in the atmosphere is due to nature? That's another hypothesis. Probably it's somewhere in between, but where? The IPCC is saying it should be all human cause. Otherwise, we don't have justification for climate fighting policies. On the other hand, we can also say, well, it can also be 100% human. Something in between is probably the case, and we're going to test these two extreme cases. This is summarized in this publication that I'm talking about today, the video, and that's in Economy, Law and Policy number 4. So here are the data. It's a little bit a complicated picture. You can see here on the top, you can see here in green, you can see here the CO2 concentration measured in the atmosphere at Mauna Loa on Hawaii. And it gives us then, you can see it also has some oscillations, because it is, of course, it's also contribution biologically that makes the oscillations, because in the summer, the northern hemisphere, where it's more land, it starts growing trees, and in winter then it's breaking these trees down again, so it oscillates. And you can see it's rising, and basically it is rising without any interruption. All these conferences, COP conferences that all the alarmists are every year holding, where they actually have a huge ecological footprint, they don't have any effect. From Kyoto to now we have Glasgow will be here this year. They don't have any effect. With a little bit more careful observation, here you can see around 1991, you can see there's a sort of like a small bend. And this, in an early publication, we have attributed at the eruption of the Pinatubo in 1991 on the Filipinos. And this caused a change in the dynamics of the CO2 in the atmosphere, actually. That is interesting, of course. But what is more interesting is to maybe, because it's not so easy to see, is to show the year-on-year increase of the CO2 in the atmosphere. And this I plotted here with these brown dots. That's a year-on-year growth, relatively so, relative to the year before. So every dot here is the percentual increase of CO2 in the atmosphere relative to the year before. And as you can see, even this yearly growth is increasing, so it goes with a faster rate. That is not, it already shows something that it's probably not a human, because that would be going in an exponential rate, which it isn't. Now, to look a little bit more detail, I've taken the last 3 years here and made a zoom in. So you get here below, you get the same plot, but as a zoom in, so the last 3 years, you see again the green, that is the CO2 in the atmosphere, and then in brown, the year-on-year growth. Now it becomes interesting. In blue, I plotted here the brown dots, which are now plotted blue because it's 2020, it's the COVID-19 year. And now we can actually see what is going on, if it is human or natural. If it is 100% natural, it should be, then we can make a projection. We can just extrapolate the line as we had before. And as you can see, this 100 nature, yes, the dots are nicely, randomly distributed around this prediction line that you can see here in the center. So yes, this makes sense. There doesn't seem anything strange going on. However, if we have 8.6% less CO2 emissions and all CO2 increase in the atmosphere is actually caused by humans, then we should expect that actually the growth would be slower than before. So it would not be business as usual. So we can also make a prediction there, and we see that actually all the data points except for the last one are above that projection, above the prediction. So apparently we can already say, like, no, it is very likely not to be human caused. So in summary, let me show you this, that again this distribution of the data points, which for the model, the prediction for the model, for the hypothesis that the CO2 increase in the atmosphere is 100% natural caused, that one is actually, yes, that can predict the data quite nicely. They are randomly distributed nicely around this prediction, while the prediction that CO2 is increasing 100% caused by humans, that actually then is overestimating the the prediction is overestimating the reality. It would be underestimating the reality. The real data points are all above the prediction. And to put it in a statistical form, this here you would have the error margin, assuming a Gaussian distribution of the errors, and you can see that the 100% natural cost for the CO2 in the atmosphere is smack on top of the distribution of the errors, while the model of H2 of that the CO2 increase in the atmosphere is 100% caused by humans. That one is already starting to fail. We already have, let's say, 1 sigma error. While it is then still too early to make 100% or a very high reliability rejection of the hypothesis that it's 100% human, we can already say that it's becoming quite unlikely that it is 100% human. And if it is unlikely that this is correct, then we already start thinking if the measures we do for doing the reducing the carbon consumption, if this is actually really necessary. But that would be, of course, a political question. We are just scientists. We just mention the facts. So we can now answer the question that we asked in the beginning. How did the COVID-19 measures have impact on the economy and on the atmosphere? Well, the answer is that the real data, the facts show that the atmosphere went on business as usual, and that hints at the hypothesis being correct that CO2 increase in the atmosphere is actually determined fully by nature and not fully by humans. And I hope you appreciate this, that this will have huge political effects, that if the CO2 reduction does not have effect on the atmosphere at all, it means that it will also not have effect on the climate that we're trying to control in some way. So this is a message for the politicians that you cannot justify the measures to control the climate based on science. Science tells you the other thing. So I hope you enjoyed this video, and I wish you further a good day.